next we will look into microcontrollers. So, after looking into microprocessors, so we have seen the microprocessors are basically the CPU. So, microcontrollers are one step ahead. So, you can consider it as computers. There are several microcontrollers. So, we will look into some of the standard ones or some of the well known microcontrollers. But of course, there are so many different microprocessors and microcontrollers are available. So, it is not possible to cover all of them in any course. But anyway, so hope that if you get exposed to one of those microcontrollers, then you can extrapolate those ideas to other microcontrollers and get the essential features there. So, 8051 happens to be one of the very prominent microcontrollers that are there in the market, and its architecture is guided by the design of this processor, and along with that we have got essential modules like say RAM, ROM and timers and all those additional peripherals. Okay. So, we will see them slowly. So, the basic components that you have in a microcontroller, the 8051 microcontroller, it has got 4 kilobytes of ROM, then 128 bytes of RAM, 4 8-bit IO ports, 2 16-bit timers or counters and 1 serial interface. So, this is the chip that we have. Okay. So, there are various manufacturers. So, this is from one such manufacturer. Now, microcontrollers, so they are they can be considered as single chip computer. So, if you remember that in a computer system we need the components like the processor, which is the CPU, then we need some memory for that, and out of that memory some part is will hold the program. So, that is so they are not going to change. So, they can be the ROM part. Then there will be some part where we will be storing some data. So, that is the RAM part, because that will require read write access, and apart from that, since the system computer system needs to interact with the outside world. So, there must be some IO ports. Okay. So, for example, in 8085 also we have seen that you can you can connect some IO devices to the ports to the data bus line and get it as IO port. So, similarly, we can have some IO port here, and some other important component like a serial communication, that is also important, because for single bit communication. So, this serial communication is useful, and when you are designing a system, then many times what we need to do is the events will needed to be occurred at some particular instance of time. So, that way we need some very precise timing. Okay. So, we can put some delays using instructions and looping like that, but that delay you can understand that we cannot go to a very refined level of granularity, because if you, even if you take the smallest say simplest possible instruction like the NOP instruction, so that requires the one complete machine cycle. So, one machine cycle, the fetch cycle, that is the 4 T state, and 4 T state so you cannot have a delay of 1 T state in that processor. So, that is the problem. So, you need some external timer or counter chip to be connected to the processor. So, if you really want some precise timing. So, for a system operation, so these are the things that we should have. Now, what is done in 80 in the microcontrollers is that all these components they are put onto a single chip. So, what are the advantages are like this, that first of all the overall system size becomes small. So, instead of having single separate chips mounted on a board, now in a single chip you have got all these components. So, overall size of the system becomes smaller. Second important thing is about the speed, like when you have got the different components mounted on a printed circuit board. So, between them the connection is the copper line. Okay. So, copper line connections, since they are external to the chip, so they will be much slower compared to the on chip, that is within the chip if I have connection. So, that compared to that these off chip connections are going to be slower. So, if you are looking for the speed enhancement, so it is better that all these components be put into the same silicon chip, okay, and that is exactly what is happening in microcontroller, that all these components they are put onto a single chip. However, So, you cannot put the resources to a very large value, otherwise the size of the chip will become very large, the footprint of the chip will become large. So, 8051 it has got 4 kilobytes of internal ROM. So, you can program this 8051 to load some program onto this ROM. Okay. So, that is the internal ROM. Then the RAM space is really small, 128 bytes only, and you will see that it is multiplexed in different ways also. Of course, you can connect external ROM and RAM chips to the microcontroller to extend the total available memory, that we will see, but internally it is like that. So, if your system is very simple, it may be that with 4 kilobyte of internal ROM and 128 bytes of RAM. So, we can realize the system. For example, if you are implementing a traffic light controller, so it may be possible that the system is very simple and we can do it with a single 8051 microcontroller instead of having separate RAM and ROM chips onto the board. 4 8-bit IO ports have been provided. So, that helps, that is a large number. So, 8-bit into 4, that is total 32-bit IO that the processor can support, okay, without any additional hardware. Then 2 16-bit timers counters are there. So, we can so that can do some precise timing calculations. So, you can control the timing, and you can also count some event that has occurred externally. So, how many, say if you are measuring, if you are counting the items passing on a conveyor belt. So, passing of every component or every item may be sending a pulse to the counter, and accordingly the counter will find out, will count the how many such items have passed. And serial interface. So, this is useful for doing some serial communication to other devices. So, if you look into the internal block diagram of 8051, so as we have said that on a bus, so these are the components that are hanging. So, we have got 4 kilobytes of ROM, 128 bytes of RAM, 4 IO ports, 1 serial port. There are 2 timers, timer 1 and timer 2, and we have got this bus control. So, bus control will be controlling the operation. There the processing unit which will be doing the processing. So, when we are discussing about the microprocessors, actually we discussed about this CPU only, assuming that this ROM, RAM, timers, IO ports and serial communication was also made part of CPU, but most of the components are outside. But in case of microcontroller, all of them are together. So, in the we have got this CPU, then the interrupt control and the oscillator that will be generating the clock signal. So, that will be coming from the that will be controlling the CPU. So, this is the internal block diagram of 8051. Other features that we have in 8051 is only one on chip oscillator. So, that is external, only one oscillator is there for the clock generation. 6 interrupt sources. So, we have got this external interrupt. So, there are 2 external interrupts, and there are 3 internal interrupts in terms of that reset, serial input output and the timers. Okay. So, 2 timers, 1 serial input output and the reset. So, these are the 6 interrupt sources that we have. Then we have got 64 kilobyte of external code space. Okay. So, that is for the program memory. So, this is so internally we have got 4 kilobyte. So, you have got 4 kilobyte of ROM. So, if you are connecting external memory, so you can go up to 64 kilobyte of external space, external ROM. For the data memory part, so it is again another 64 kilobyte of external data memory. So, code memory and data memory, if you take it separately, so it is 64 plus 64, total 128 kilobyte of memory that you can connect to the 8051 system. Out of that, half of it will be program memory, half of it will be data memory. In many realizations, what we do is that we merge this code and data memory together, and we get only 64 kilobyte as the external memory. So, which can be configured both as data memory and program memory. So, that may be useful in many applications. Now, when you are using this external memory, external code memory, so there is a strobe which is known as the program store enable or PSN. So, this PSEN bit, so this particular bit, so it will be controlling the read operation. On the other hand, for the data memory access, so we have got this read and write. So, in case of normal processor or 8085, we have seen that whenever we are trying to access outside the memory, so there were read and write controls. So, for ROM access, only the read line should be connected to the read of the ROM. For the RAM access, the read and write lines are to be connected to the read and write pins of the RAM. But in case of 8051, since program memory and data memory are totally separate, okay, so the program memory is controlled by this PSEN signal, PSEN signal, whereas the data memory is controlled by read and write signal. So, when the 8051 is accessing program code, so it will not activate this read and write signal. So, we have to be careful in our design, because then it will be through the strobe given will be on the this program store enable line. On the other hand, when it is doing the read access or data access, so it will be activating only the read and write lines, not the PSEN line. So, we have so that way we have to be careful. And this code memory is selectable by this EA, external access. So, whether, as we said that there is 4 kilobyte of external memory. So, you can at any point of time you can say whether you want to access external memory or internal memory. So, that way you can have this EA. So, this external access, there is a pin that you can configure, and you can set it to 0 or 1 accordingly. The instruction will access internal memory or external memory for code access. And we can, as I have already said, that we may have external memory as both data and code. So, that is possible. So, why this 8051 all on a sudden came? So, this has come because of the new type of systems that we have, they are known as embedded systems. So, an embedded system, it is closely integrated with the main system, and it it may be that in the overall system this embedded system is a part. For example, the washing machine. So, washing machine has got the interfaces which are to the outside world. So, they will see a set of buttons, but internally there are computations, like when the drum is rotated, for how many turns it will be rotated, what will be the temperature, and it will sense the water level and all that. So, all those are done by the embedded system. Or when you are driving a car, there are many processors which are controlling different operations, starting from this steering, fuel injection, anti-brake, then this braking system, this airbags, then we have got power windows and all that. So, all of them are processors are there who are doing this computation, but from the user's point of view, so we do not see those processors. So, we just see the overall system. So, that these are the examples of embedded system. So, these processors, they may not directly interact with the environment, they may be interacting with the system into which it is put into. So, it is a part of a bigger system. So, it may be interacting with the bigger system. So, a typical example is the car ignition control. Okay. So, that is so that, as I have already said, there are many such processors in the car, that will be that will help in driving the car and its control. So, an embedded product uses microprocessor or microcontroller to do one task only. So, the task is fixed, like when you are driving a car. So, the operations that these processors need to do, that is fixed. Okay. So, on a car processor, I will not try to say run a program which will find the roots of a quadratic equation. So, will not do that, but the processor is doing other things like this fuel injection, steering control and all that. So, those are being done. So, they are doing only one task at a time. So, if you are using microprocessor, as I have said that okay, the size of the system may become large. So, as a result, we are doing some we are putting a microcontrollers, and since we are doing only a single application or only a small set of applications on a microcontroller based system or an embedded system. So, we know the programs that we need to execute. So, we can burn those programs to the ROM directly. So, unlike a general system where different users may come up with different programs. So, we need to load that programs onto RAM, and from there we need to execute, but for an embedded application the programs are fixed. Okay. So, we can just load, we can burn those programs onto the ROM, so that these programs only those programs will be executed by the processor. So, that is the point where this 8051 may be useful. Typical examples of embedded system like keyboard, printer, video game player, MP3 music players, so embedded monitors, mobile phones, cameras, okay. So, automotive control. So, all these are different examples of embedded systems. So, they have got these processors built into it. Now, how do you choose a microcontroller? As I have said that there are several microcontrollers available in the market, and in fact 8051 also there are variants. Okay. So, we have got 8031, we have got 8052 like that, and their capacities are varying, like the 8031 will not have any internal ROM, 8052 will have one more timer in it. So, that way the features will vary. So, which one to take? Okay. So, for the criteria for choosing a microcontroller is, first of all, the meeting the computing needs of the task efficiently and cost effectively. So, speed should match the amount of the speed of the processor should match my requirement, because most of the time these embedded applications that we have, so they are real time in nature. So, the task has to be completed within some fixed amount of time. So, if the processor is slow, so will not be able to complete the task within the reasonable amount of time. So, the speed of the processor is one parameter. Then the amount of ROM and RAM that we have in the system. If the ROM is small and my application have program size is large, then I need to connect external memory to the chip. Okay, that way the footprint will go up. Okay, so, we can have if we go for a higher family of microcontroller, then possibly my program will fit into the ROM that is available there, and we will be able to hold that task within the microcontroller itself. And the RAM also, like how much of data that we need to store, okay, basically the temporary data that we have. So, how much of those temporary data that we need to store. For example, 8051 it has got only 128 bytes of RAM, internal RAM. So, if you need more RAM space, then you have to connect external RAM chip. So, how is it, so are we going to do that? So, if we find that going to the next higher family, so I can manage the RAM space, the variables, then possibly that is fine. Number of IO ports, like we can have 8051 it has got 32 IO bits, 4 IO ports, and so if that is sufficient, then it is okay. If it is not, we have to go for the higher one. The timers, number of timers that we have. So, each timer may be dedicated for controlling one operation. So, if you need precise timing for say more than 2 operation, then possibly, and they are parallelly. So, then possibly we cannot go for 8051. Then size of the system, its packaging, its power consumption. So, they all will contribute to the choice of the microcontroller. Second important thing is the upgradation. So, today we are using some microcontroller. So, tomorrow can we go to the next higher microcontroller in my system. As a result, the system performance will be enhanced, and but at the same time I do not want to change the hardware that we have too much. Okay. So, the pin configuration and this thing, so the software compatibility, so they should be there. So, it should be easy to upgrade, and the cost per unit. So, when you have built a system based on a microcontroller, then every unit that you sell, the microcontroller price will come into picture. So, if the cost per unit is not low, then the cost of the system may get dominated by the cost of the microcontroller. So, that way we have to be careful. Second important thing that we have is the availability of software development tools. Now, as some time back I have said that there are so many microprocessors and microcontrollers that you possibly cannot learn about the assembly language programming of all those processors. So, it is desirable that we can write our program, our control program in some high level language like say C, and then the compiler should be there which will translate this C code into the machine code of the processor. So, these assemblers, debuggers, compilers, emulators, simulator, technical support, so all these should be available for the microcontroller that we take. Wide availability, it should be widely available, and there is reliable sources for the microcontroller. So, we should have these easy availability, you can say, okay, and it is available in large amounts. So, these are the criteria that will guide us to choose the microcontroller. So, as you can see that some of these decisions are based on the electronics that we have, like this speed, amount of ROM, RAM, etc., but many of them are economic also, like say availability and of reliable resources and all that. So, they are not there, and similarly the development platform. So, they do not that is not again the part of the basic hardware. So, they are the additional things that are done by the vendor to promote the product, so that the developers can use those platform to develop product on or develop applications on that product. So, that way you see that many decisions are not done solely based on the quality of the processor, but the quality of other things as well. If you look into this 8051 family, then this ROM type. So, 8031 it does not have any ROM, 8051, 8052, then 8751, 8752. So, 8051 they have got mask ROM, 8751 they have got EEPROM. So, they are electrically programmable ROM, and and then we have got flash EEPROM in 89 series. So, 89 series has got so many processors, and they have got EEPROM, electrically erasable programmable read only memory. So, we have, so these are some of the examples that you see. So, this first two words, so they will tell the manufacturer, the AT stands for Atmel, C stands for the technology, the CMOS technology, and LV is the low power version. Okay. So, the supply voltage is low, 3.0 volt, whereas the normal processor the supply voltage will be 5 volt. So, this way there are many vendors of this 8051 series of processors, and accordingly you can find out the you can see the series number there. So, if you try to compare across these family members, so this we are just comparing the 89 series. So, 8951, which is basically the 8051 only. So, it is 4 kilobyte of RAM, ROM, 128 bytes of RAM, 2 timers, 6 interrupt sources, and 32 IO pins. 8952 or 8052, it has got 8 kilobytes of ROM, 256 bytes of RAM. So, you see the ROM and RAM have been doubled, then timer is also one more, interrupt sources are also 2 more, IO pin remains same. 8953, so they are, the ROM size is increasing further. So, you see that we have got many choices. Okay. So, we have got many choices. So, based on the application that we have, we can go for additional the higher family of processor. And this one this 891051 and 892051. So, they have got some additional things like watchdog timer. So, they are useful when you have got some deadlines for tasks and you want to detect whether the task has missed its deadline or not. So, for those type of applications, so we need these watchdog timers. So, then the analog comparator, so analog voltage comparator, then the in system programmable, that is when the system is operating. So, can you change the program? So, those series, so the AC, so marked as AC, so they have got these features. So, naturally the better processors, we have got better flexibility facilities, but the cost of the system will also go up. So, this is the overall diagram that we have. So, we will explain it by parts. Okay. So, so in the schematic, so this is a better view of the processor. So, you can see that okay, we have got, I said that there are 4 ports. So, this is P0, P1, P2 and P3. So, these are the 4 ports that we have, and they are all 8-bit ports. Then we have got this RST, which is the reset. Okay. Then there is EA bar, external access. So, they are actually this RST and EA bar. So, they are coming to the chip. So, they are input to the chip, it is not shown here explicitly. So, this EA bar, so if this line is made 0, that means the system designer wants that the 8051 should use the code space from the external memory, it should take the code from the external memory, external ROM. And for normal operation, we should set this EA bar pin to 1. So, if this pin is made high, then the 8051 when it is accessing code, it will be using the internal RAM, internal ROM. And we have got this So, many of these pins, so they are multiplexed, like you see that this P0 the port 0 the bit, so these pins pin number 32 to 39. So, they act as the port pin as well as the multiplexed address data bus AD0 through AD7. So, here also like 8085 the bus is multiplexed. So, we have got this lower order address bus and data bus multiplexed AD0 to AD7. Then if you look into port 2, here also you see that the it is the pins, they are multifunctional pin, and they will act as IO pin as well as the higher order address bus. So, if you are connecting some external memory, then this A8, so this all these pins 21 to 28 and 32 to 39. So, they will be used by the external data bus, external address and data bus. So, you cannot use those ports for IO device for IO operation. Okay. Similarly, if you look into this port 3, you will find that these pins are also multiplex, that is pin number the pin number 17, it acts as the bit 7 of port P3 as well as the read bar signal. So, when if you are connecting external memory, then these read bar write bar lines are required, and then you cannot use this port 3 as the port for accessing as port bits. Okay. So, all these are there. Similarly, this 3.0 is used for receive data and 3.1 is used for transmit data. So, these are for serial communication, like we have got SID and SOD in case of 8085. So, here we have got TXD and RXD. Then these are the two interrupts that we have from outside, INT0 and INT1. Then this T0 and T1, so they are for the counter operation of the timers. Okay, and then this ALE is same as that we have in 8085, and PSEN bar. So, this is for the external memory access, the you can give the you can connect to the read bar pin of the ROM. Okay. Then we have got the crystals.